Namaste students, welcome you all in the lecture number 2 of the periodic classification of elements, that is the second last chapter of the chemistry section in the science. Okay, here let me inform you, as in the earlier class I told you, first group, what type of elements are kept. These are based on the oxides and the hydrides with the general formula R2O and RH. Similarly, in the second group, RO and RH2. And in the third group, R2O3 and RH3. Now let us come to the fourth group. Up to group number 3, I have informed you in the previous class. Let us see the group number 4. Okay, here RO2 is the general formula for the oxides and RH4 is the general formula for the hydrides. Suppose for example we have the element in the fourth group, that is carbon, in the second period. Okay, carbon is forming the oxide with the general formula RO2, so it will be CO2. R is the element, so if you place the C carbon in place of R, then it will be CO2. Similarly, silicon Si, so it will be SiO2. Okay, here SiO2, here CO2. And in the titanium, TiO2, same thing. Okay, GeO2 for gallium. Then zirconium, ZrO2, SnO2, then HtO2, PbO2. Alright, in all the cases this general formula is applicable and we are able to get the oxide of the same kind. Then RH4 also. Okay, if hydrides we see RH4, then it will be what? CH4, methane we are getting now. Similarly, SiH4, then TiH4, GeH4, ZrH4, SnH4. So in the same way we are getting the here hydrides and oxides based on the general formula. Similarly we are getting the compounds based on the general formula R2O5 for the whom? Group number 5. So R2O5, then here it will be N2O5, P2O5, then V2O5, AS2O5, then NB2O5, SB2O5. Okay, for all the elements we can get the oxides. Now come to the hydrides, RH3, so NH3 ammonia, then PH3 phosphine, then vanadium, okay, VH3, ASH3, NBH3. Okay, so fifth period also, fifth group also over. Now sixth group, let us see, RO3. So here what will be? For the oxygen what will be? Oxide O3. Okay, then SO3, then CR2O3, CrO3, chromium oxide, then SeO3, then MoO3, TeO3, WO3. Alright, so here oxides also over for the sixth group. Now RH2 for hydrides, so OH2. Okay, then CrH2, SeH2. So here also we can see that these general formulas are applicable for all the elements present here. Okay, now for the seventh group, R2O7, F2O7, then Cl2O7, okay, Mn2O7, Br2O7, TeO27, Tc2O7, I2O7. Okay, oxides over. Now similarly for RH, FH, ClH, MnH, TCH, IH. Okay, now lastly what is there? Here we can see the last group. Okay, in the last group what is there? Transition elements are present with the general formula RO4. Okay, here we are getting in the fourth period, this is visible. In the fourth period what is there? Iron, cobalt and nickel. In the fifth period here rubidium, rhodium and palladium. And sixth period there is OS, IR and platinum. Alright, here FeO4, then CO4, NiO4, then RuO4, RHO4, PdO4, OSO4, IrO4, PtO4. Okay, with the general formula RO4, all the oxides are produced here with this group. Understand, students? So this is why he has kept the elements in such a manner, because they were following the general formula as given in the periodic table from group number 1 to group number 8. Okay, everything is visible here. So this is about the Mendeleev's periodic classification, or you can say periodic table. Now come to the next point. Here the modern periodic table. What is modern periodic table? In 1913, what was there? In the 1913, the Henry and Moseley showed that the atomic number of an element is a more fundamental property than its atomic mass. The most fundamental property which was selected by the Daubigny in his triads, and by the Newland in his octave law, and by the Mendeleev in his periodic classification, all were based on the atomic mass. Okay. Now in the modern periodic table in 1913, the Henry and Moseley, two different scientists, they decided to better to have the most fundamental property, that is the atomic number, in place of the atomic mass, because here many anomalies, many drawbacks were found in all the periodic classification given by different scientists. But they thought, let us see, experiment on the atomic number as a basic fundamental property, in which we have seen that atomic number always increase by 1 when we are going from left to right in a periodic table, modern periodic table. Then atomic number increases by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is not in the fractional number. Okay, not in the point. So it was the fundamental property, and when we do the electronic configuration, all the elements are having the same number of the valence electron in the valence shell. So those are having the same number of valence electrons in the valence shell, such type of elements are kept in the same group. So that is why it was decided that it is the most fundamental property, and it can be used for the classification of elements. Okay, basis of the classification of elements. Now come to the modern periodic law. What is the modern periodic law? The physical and chemical properties of elements are the periodic function of their atomic number. That was the modern periodic law given by the Henry and Moseley in their periodic classification, and which was given the name modern periodic law. As per the modern periodic law, they stated that physical and chemical properties of all the elements are the periodic function of their atomic number. When we arrange the elements in the increasing order of the atomic number, then their atomic number is increasing by 1, or we can say they are the periodic function of their atomic number. There is a repetition of the same kind of the properties of the elements after a certain interval of time. After certain interval of time, we find that again the same elements come which is having the same kind of the chemical as well as the physical properties. That is why we can say the physical and chemical properties of the elements are the periodic function of their atomic masses. Okay. Now modern periodic table based on the atomic number of the elements. This is the main thing. What is the principle? Principle is that all the elements are classified in the increasing order of their atomic number. Okay, atomic number, most fundamental property. Then atomic number is equal to the number of protons. I told you in the previous classes many times that atomic number is equal to the number of protons present in the nucleus of an atom of an element. Okay. Modern periodic table consists of 18 vertical column. 18 vertical column. These are known as group. Okay, these are called group. Like that vertical columns are there no in the periodic table. So these vertical columns are known as what? Groups. Clear? And Another is they have the 7 horizontal rows, like that rows are there no in the modern periodic table. So these horizontal rows are there, these are called the periods. Two things we have to remember, groups and period. Vertical columns are group and horizontal rows are called the periods. Clear? Then on moving from left to right in a period, the number of valence electrons increases from the elements. Okay, we can say when we are moving from left to right in a period, the number of valence electron increases. Okay, and when we are seeing, suppose sodium, okay, first element is sodium, and after that what is there, magnesium. Okay, in these cases we will find that there is increase of the valence electron by 1 while moving from left to right. In the valence cell, number of electrons are increasing by 1. Okay, now come to the next point. On moving from left to right in a period, number of cells remain same. All the elements of a group of the periodic table have the same number of valence electrons. There is no increase in the valence electron, it remains same. Okay, on moving from left to right in a period, number of cells remain same. All the elements of a group of the periodic table have the same number of what? Valence electrons. In the case of the group, valence electrons remain same. In the case of a period, this valence electron increases by 1. Okay, when we are moving from left to right, number of cells remain same. First thing, cells will remain same, and the elements of a group of the periodic table have the same number of valence electrons. Okay, now come to the next point. Trends. What trends can be seen when we are doing the classification of elements in the modern periodic table? Trends in the modern periodic table is that valency, atomic size, metallic and non-metallic characters, and electronegativity. What happens to them when we are moving from left to right in a period and top to bottom in the group? Okay, so let us see one by one. Number one is the valency. The valency of an element is determined by the number of valence electrons present in the outermost cell of its atom. Clear? That is the combining capacity of the element is known as its valency. You have got in class 9. What is the combining capacity? How many atoms can combine with the another atom? Suppose CO2. Okay, combining capacity of the oxygen and the carbon. Carbon can combine with the 2 atom of oxygen. So combining capacity of the carbon is 2. Oxygen can combine with the 1 atom of the carbon. So its combining capacity is 1. Okay, that is called the combining capacity. That is also known as valency. In the period, on moving from left to right in a period, the valency first increases from 1 to 4 and then decreases to 0. Suppose lithium. Okay, valency increases. First 1 is there, then 2, then 3, then 4. It is the first period. If you see the modern periodic table, it will be the first period. Okay, so 1 to 4 it is increasing. After that decreasing up to 0. Nitrogen will have 3, started decreasing. Then oxygen will have 2, fluorine will have 1, and ultimately neon, the inert gas, it will have the 0 valency. So first from 1 to 4 it is increasing, and after that from nitrogen to neon it is decreasing. Okay, 4, 3, 2, 1 and 0. So this is the trend found in the case of the valency when moving from left to right in a periodic table in a period. Okay. Now come to the next point. In the groups, on moving from top to bottom in a group, what will be observed by you? On moving from top to bottom in a group, the valency remains same because the number of valence electrons remains the same. Example, valency of the first group element 1, valency of the second group it is 2. Okay, it is never changing. it is not changing, it remains same. Suppose lithium, okay, let me tell you valency of the hydrogen here. Hydrogen is not included in the first group, okay, so don't worry. Lithium, okay, sodium, potassium, rubidium, cesium and francium. Here in all the cases you will find its valency is 1, okay, their valencies are 1. When we do the electronic configuration we will find that valency is found to be 1. Why it happens? We can do the electronic configuration. Atomic number of lithium is 3, sodium is 11 and potassium is it may be 18 or 19, 3, 11, after that I think 19. Okay, so here lithium C 2, 1 as atomic number is 3, sodium 2, 8, 1, potassium 2, 8, 8, 1. Okay, so here we are finding that all are having valency 1. Clear? So we should remember that when we are moving from top to bottom in a group, then valency remains same whether it is the first group or it is the second group. Okay, all are showing the same kind of valency. Now next come atomic size. What happens to the atomic size? Atomic size refers to the radius of an atom. Okay, it is the distance between the center of the nucleus and the outermost cell of an isolated atom. In the periods on moving from left to right in a period, atomic size decreases because nuclear charge increases. Nuclear charge means the number of protons are increasing in the center in the nucleus. Okay, so number of protons when increases, then we can say that nuclear charge is increasing. Okay, on moving from left to right in a period, atomic size decreases because nuclear charge increases. Keep in the mind, this point is very important. Okay, maximum questions are asked from this section. Example size of the second period element. Okay, lithium, then beryllium, boron, carbon, nitrogen, oxygen, fluorine. This size is going on decreasing. Size is going on decreasing. Understand why it is decreasing? Because the nuclear charge is increasing. Because atomic number is increasing, so number of protons also in the nucleus will increase. Clear, students? Thank you. We'll meet in the another class.